Hello there everyone. Well, following yesterday's announcement about lockdown and the exams, we still don't really know exactly what's expected of us, other than that it is really important we keep working, because we don't know how much evidence is going to be needed this time. They've got more time to demand more, so we need to make sure that we're able to show them what's going on. And to make sure that happens, I'd like you to get into the habit, please, of uploading back onto class charts, or you can just email it to me if you like, just a little photo of just some of your work from each lesson that we do. Now, the lesson I'm going to do today is one which a lot of it will be very familiar to those of you in 13C, because we did do a bit of it in the last lesson before Christmas, but the others haven't seen it at all, and I think, to be honest, it'd be good for everyone to do it anyway. So if you've got any issues with that, please email me and we can have a look at that. But basically, you've got to do it. So okay, I'll get cracking on then. So we're differentiating trigonometric functions. Here's our first example then, differentiating trigonometric functions. If y equals tan x, what is going to be the differential of tan x? And in order to do that, we already know how to do sine x and cos x, and we know that tan x is sine x over cos x. And in order to do that, if you look in your formula booklet, and the differentiation, it's just got this. Now, these other bits we're going to come to in a moment, but here we go. We've got function of x divided by a different function of x, and then we've got a little formula for what we can do with that. So this is what we're going to be looking at now. Now, those of you who did this before Christmas, see if you can do it now. Pause the video and then go on. Otherwise, you might just want to watch this. So first of all, if we just write down what the formula is. The formula is saying that if our function of x is, well, I suppose we could call that, actually in the book, in the formula booklet, it doesn't do this, but it does, because in the formula booklet it just has a heading of it and it uses the same f of x. Really, we should have different letters there. So then that, what we're then thinking of is that its differential is going to be, you take the differential of the one on the top and you multiply it just by the function on the bottom, and then you take from that the reverse, so the differential of the one on the bottom multiplied by the one on the top, and underneath you get the one on the bottom squared. So what's that going to look like for us here? Well, if we know that if we say that f of x is tan x, then tan x is sine x over cos x. And moving on, we can then say, someone will not, so we've got our differential being, so it's the differential of the one on the top. Now, how do we do that again? Remember our circle of truth. So we've got sine x, cos x, differentiates to negative sine x, differentiates to negative cos x. So we've got that circle of truth. Keep that there. Meaning that our sine x differentiates to cos x, and we're going to times cos x by what's on the bottom, which is cos x. So that's going to give us cos squared x for that one. Then we're going to have minus a differential of what's on the bottom, so that's negative sine x, which is going to be multiplied by what's on the top, which is sine x. So that would be negative sine squared x all over cos squared x. And take a negative is going to be plus, isn't it? So let's just do that, but also let's split this fraction like that, because that allows us to get a cos squared x over cos squared x is going to be 1, isn't it? So that's going to equal 1, and then we're going to need to split this as well, because sine squared x, remembering that it is sine squared x plus cos squared x is identical to 1. We all know that. So as this is all about cos squareds, let's get rid of the sine squared x and call that 1 take cos squared x. Now we're going to do a similar trick here that we've just done. So we're going to have 1 over cos squared x there, and then that's going to be take cos squared x over cos squared x, and that's all going to clean up to be 1. 1 take 1 is nothing, so we're just left with 1 over cos squared x. And we know we don't call that 1 over cos squared x, do we? We like to call that sec squared x. So that is the simplest way we can say it. So we have differentiated tan x. So leading on from that, the formula booklet says something that looks very much like this. Function of x equals tan kx, then the differential of that will be k sec squared kx. It doesn't look exactly like that in the book. What it looks like is this here. So just be aware of that. Right, so how would we use this? Well, have a little look at this one. What if I was to ask you to differentiate y equals x tan 2x? So pause it and have a little go. Remembering, if you need a little clue, you're going to need to use the product rule here. So if you let u equal x and v equal tan 2x, we then need to differentiate both of these. So du dx will be 1, won't it? And dv dx, we can look to the our formula booklet to help us out there and give us 2x squared 2x, because the 2 being the k. Right, now what does the product rule say? The product rule, which is not in the formula booklet, says the differential is going to be u times dv dx plus the same thing the other way around, v du dx. And although that's not in the formula booklet, the quotient rule is, and you can sort of see it inside it, but we'll come back to that again in a bit. So our u was x, so we're going to have x times dv dx, so it's x times 2 sec squared 2x, and then we're going to have v, which is tan 2x multiplied by du dx, which is just 1, so we're just going to have tan 2x, so we're going to be adding tan 2x to that. So we just need to clean this up a bit. If we times 2 by x, we call that 2x, don't we? So we can just call that 2x sec squared 2x plus tan 2x, and that's that done. Okay, let's have a look at another one. How about differentiating y equals tan to the power 4x. I'm going to pause it and have a go. You'll need to be using the chain rule this time, which we learnt just before we did the product rule. So, the chain rule, looking at saying that we can say that dy dx is going to be dy by du times du by dx, so that the u's cancel out, and we would be letting u equal tan x here, because then we can say y equals u to the power 4, and therefore dy du will be 4u cubed. Now that we know that substituting the u back in there, we can say it's 4 tan cubed x. So that's our dy du, and our du dx is going to be, so u equals tan x, so our du by dx comes about from the fact that we've just gone through this whole thing, haven't we, with tan x being sec squared x, and therefore the chain rule, we've got to multiply these two together, haven't we? So we can say dy by dx is dy by du, which is 4 tan cubed x, and that's going to be multiplied by sec squared x. Right, just two more little examples to go, and then that'll be that for today. I've got you can do, and then we'll carry on with a bit more of this tomorrow. So again, we're dividing here, so we're looking at the quotient rule. So we've got our f of x being cosec 2x, and what do we do for this? Well, we can have a little look at our tables again here, where it says cosec kx, and it gives us this bit here telling us minus k cosec kx cot kx. So look out your tables if you haven't got them at the moment, and we do have, I'll make sure that I'll put another PDF on attached to this so that you can find them easy enough. So that'll be minus 2 cosec 2 x cot 2 x. So it's rather a lot, I know, but there you go. Then we've got on the bottom, our function is x squared, and differentiating that is rather nice, isn't it? Just 2x. Now we just need to fill it in according to what's there in the formula booklet, and we can say that dy by dx is going to equal, and then start popping it in. So we've got the differentiated top one times by that one. So what's the nicest way to write that? Probably minus 2x squared cosec 2x cot 2x, and then we're going to be taking the function on the top cosec 2x multiplied by other one from there. So that's, we can just put the 2x in front of cosec 2x, and then on the bottom we need that bottom function squared, don't we? So that is that one. So it's x squared squared, and if we do that we get x to the power 4. At this moment, just look to see if there's anything we can simplify by, and there is, because we've got two terms on the top, haven't we? This one here has got an x in it, this has got an x in it, and that's got an x in it. So we can do all of that and then just write it out one more time neatly. So we've got minus 2x cosec 2x cot 2x, take 2 cosec 2x all over x cubed. And you may have noticed that we could possibly make this look a little neater, couldn't we, by factorising. So we've still got the x cubed on the bottom, but on the top we've actually got 2 cosec 2x that on both of them, so we can do that, and they are negative on both of them, so we've got negative 2 cosec 2x, and then what goes in the bracket, we've got x times cot 2x, x cot 2x, and then actually that is all of this one, isn't it? So that's rather nice, and that's going to have to be plus 1, so that when we multiply it out we get the negative there. Okay, and just to finish off, we're going to have a go at differentiating y equals sec cubed x, and for that you're just going to be wanting to use the chain rule. So give it a go before you watch me make sure that you've got basically the same thing. So it's let u equal sec x, then we've got y equals u cubed. We can differentiate, can't we? dy by du is 3u squared, which means we can then substitute the sec x back in there and call that 3 sec squared x, and then we need to do du by dx, don't we? So if we've got u equaling sec x, then we can say that du dx equals, and this is time to look back in your formula books again, and it tells us that sec kx is k sec kx tan kx, so we don't need to worry about the k's because we've just got sec x, and we can, so that differentiated is sec x tan x. So what have we got? We've got dy by dx is going to be dy by du times du by dx, so it's going to be 3 sec squared x times sec x tan x, and that all comes together nicely and just gives us another sec, so sec cubed x tan x, and that's done. Now, having done that, I don't want you to go crazy on the 9f exercise because there's still some more examples for us to look at, but it's just going to take, there's just too much to cover. So exercise 9f on page 249, I'd like you to have a go at doing question 1 and 2. There's a few on there. I'll upload those questions as well. All right, okay, see you tomorrow, folks. Okay, the next example is a show that. So have a little go at this. There's a couple of ways you could do it. You could do it by using the quotient rule, or you could just do it using the chain rule. So go for whichever one you fancy. I'm going to do the quotient rule first. So the quotient rule is the one that's in your booklet. I'll show you again, just down here. So you need to demonstrate it using that. So we can so if y equals cosec x, we can say that that is 1 over sine x, and then you can let function x equal 1 and function g of x equal sine x. Differentiating 1 gives you nothing, and using our circle of truth, differentiating sine x gives us cos x. And then you just need to plug it in to what's there in the formula booklet. So you just need to write down that you've got your f of x over your g of x, and then start filling in what we've got. We've got our differentiated f, which is 0, multiplied by our g, which is sine x, and then we're going to be taking away from that our f of x multiplied by the differential of g being cos x, and it's all going to be divided by the function on the bottom squared. So then we get not the function on the bottom, not the differentiated one. So then we get sine squared x on the bottom. Clean this up a little bit. We've got 0 there minus cos x on the top over sine squared x, and we're virtually there. All we need to do is then split that into a multiplied 1 over sine x, multiply the bottom ones would give you sine squared x on the top, and you've got cos x there. And if we look back up here, minus cosec x is 1 over sine x, and cos x over sine x is tan x upside down, or sorry, the reciprocal of tan x. So that gives us our cot x there, and we just need to then divvy in as required. So put that in there. Okay, so that's it done that way. I just wanted to show you in case you wanted to have a go at, because that might not occur to you in an exam. You might think of it this way. So 1 over sine x, and replacing u with sine x, and then you can differentiate dy by du would give you that, and all comes together. I'm not going to talk through it all, but you can pause it and have a look and work out. If you'd like me to talk further about that, let me know. Okay.